Thanks for joining my talk today. I'm going to talk to you about post-quantum cryptography and why that's important to Sitecore developers right now. It's quite a forward-looking topic. Quantum solutions or quantum computing is being developed by government agencies at the moment. It poses quite a big threat, but I'll get into that during my presentation. First, I'll talk a little bit about me. I'm an engineering manager. I work at Macmillan Cancer Support. I'm a first-time Sitecore Technology MVP for this year. Very proud of that and being part of such a great community. And I've been working with Sitecore for just over 7 years or so, and I live in London. If you want to connect with me on LinkedIn, you can scan the QR code. I can leave it up at the end as well if you want, or you can come and chat to me afterwards if you have any questions. For today's agenda, I'm going to talk a little bit about the background and history and where the threat is. I'm going to give a brief introduction to quantum computing. I'm going to talk a little bit about the problem with TLS 1.2. I'm going to go through some of the actions that we can take now and some of the actions that we're also taking at Macmillan. I'm going to talk about some Sitecore options for TLS 1.3 for XM and XP customers, because TLS 1.3 is not officially supported yet for XM or XP customers. I'm going to talk about the future of post-quantum cryptography as well, and then I have a slide on some further reading because I've written a blog post about this as well. So just to take you back a little bit, so I'll start with a bit of a history lesson. Richard Potter yesterday, he talked about the 1990s. I'm actually going to go even much further back than that. I'm going to go all the way back to the 1940s and the Second World War. Because I went to Bletchley Park with my wife last year, and it's a really interesting place. If you haven't been there, there's a lovely kind of museum and lots of huts where they were doing code breaking during the Second World War. And actually, the problems that we face now are quite similar to the problems that those code breakers were facing during that time, and the people that were trying to also protect those communications from being broken. So during the Second World War, the British and allies were able to break the ciphers from the German-engineered Enigma machine, which was previously thought unbreakable. They were able to find messages that were being sent along the front lines, and this actually proved to be extremely helpful for the Allies during the Second World War, and probably strongly contributed towards them winning the war in the end. 85 years later, quantum computing, it poses a lot of the same types of problems. So how do we protect our communications from a more powerful machine? How do we do it quickly in a race against the clock? How can we prevent exploitation of mathematical weaknesses? How can we work collaboratively with allies and others to protect our data? And like Richard Potter also mentioned yesterday in his presentation, the rapid advances in computing power, it requires us to remain proactive to ensure we migrate before data is breached. So that's really important, to be proactive in this situation rather than reactive. So 1 second. The impact on quantum computing as well could potentially be quite revolutionary for Macmillan, and I just wanted to mention that it's not just a threat that is a concern, but it's also got a really exciting potential. It's got the potential for us at Macmillan Cancer Support, at least, to revolutionize individualized cancer treatments, and that is quite exciting for us really, because we'll be able to make much more accurate predictions with regards to cancer treatments than we would have been able to make before, based on people's DNA sequencing and diagnosis and so forth. So what is quantum computing and where's the threat? So quantum computing, it presents a new and unique set of challenges for developers and information security professionals. By 2029, Microsoft is going to be releasing quantum safe capabilities in Azure. And in Microsoft 365 by 2033. Now, I'll talk you through a little bit about how quantum computing works differently to a traditional computer. On a traditional computer, you typically have a set of zeros and ones, right? And it could be either one of the two states. On a quantum computer, it could either be a 0 or a 1, or it could be both states at once. And actually, in that equation that I've got on the screen up there, the A and the B in that equation for the qubit, which is how you would store data on a quantum computer, are probability amplitudes. So basically, it allows you to have an amplification of the right answer because you can have parallelism as the data is stored on your computer. So for example, 3 bits on a traditional computer can have one of 8 states, whereas on a quantum computer, it can have a superposition of all 8 states at once. So in terms of where the threats come from, like I mentioned, nation states at the moment are investing huge amounts of money into quantum computing. They're also subcontracting this out, probably in places like Russia. They're also subcontracting that out to organized criminal organizations. And there is evidence that they're also using some of that they're also subcontracting out to criminal organizations, particularly to harvest data. And I'll get onto the harvest now and decrypt later problem, which is one we're facing right now, actually, on the next slide. And the reason why some of this is important to Macmillan too is that we collect and we store large amounts of special category health data. Exposure of this kind of data would be a regulatory issue, it would be deeply personal, it could be reputational for Macmillan, and it could also be perceived as a betrayal of trust against the most vulnerable in society, because often it's people that are giving us the data, they are at a low moment in their life, maybe after a cancer diagnosis, for example. So it's really important that we try to protect that special category data. That also needs to be treated differently under GDPR regulations from being breached. So just to talk to you about where the problem exists now. So you've got the harvest now, decrypt later problem, as it's referred to. So for example, if you're sitting and you're connected to public Wi-Fi in a cafe or even in this hotel, if you are thinking that you're connecting to a website over HTTPS, and you're filling in your details on the form or your bank details or logging into the website, somebody else could be sitting on that network and they could be intercepting the network traffic using a machine that's on that network with a tool like Wireshark, for example. Now, at the moment, because that data is encrypted, typically using TLS 1.2 or TLS 1.3, at the moment, that data, there's not the quantum computing capability currently to be able to decipher that data, to be able to extract meaningful content out of it. But there is probably people sitting in airports at the moment trying to collect data that is being harvested from these types of communications, which potentially then can be decrypted later when the capability is ready for quantum computers to be able to break the existing ciphers that we're using to currently protect our communications. Typically, like RSA encryption or 2048-bit encryption, which is being used currently, it's based upon prime numbers. So you typically have a very, very large prime number that is multiplied by another very large prime number to create a composite number. Now, that composite number forms part of your public key that you're sharing when you're sharing the web page on your website. And it's very easy to create that composite number from 2 large prime numbers, but it's very difficult to go backwards to find the very 2 large prime numbers that created that composite number to begin with. So the numbers I put on the screen here are only for illustrative purposes. The numbers in reality would be much, much bigger than this, of course. And I just want to talk about the slight difference between TLS 1.2 and TLS 1.3 as well, is that with TLS 1.3, and if you're using that at the moment, you can't decrypt information that has been harvested in the past. So therefore, it's important as well that we look to think about how we can move towards TLS 1.3. And the threat of harvested data is also amplified by retrieval augmented generation. I think it was mentioned in some of the talks that we've already been through, that insights can also be gathered from vast quantities of stolen data much more easily now than it might have been before, through having retrieval augmented generation with large language models. So what should we be doing now? You want to make sure that you encrypt your data at rest. You want to make sure you encrypt your data in transit, ideally with TLS 1.3, where supported, as I've mentioned, because TLS 1.3 as well, although it's not quantum safe, it provides forward secrecy. TLS 1.3 will also support future post-quantum algorithms, and the Internet Engineering Task Force are prioritizing post-quantum solutions for TLS 1.3 only. Now, on TLS 1.3, with the current algorithms, it is still susceptible to being decrypted using quantum computing in the future, but like I said, you can't go back once you've had communications over TLS 1.3 to decrypt something that has already been sent previously. You can use tools within your site like SSL Labs to work out how your website is encrypting traffic. So if you're wondering, how to stay secure, that's something that you can, a tool that you can use. As well as the blast radius is the next thing that you need to think about. If you have a data breach, you probably want to think about like limiting how big that data breach is going to be. So one thing that we're doing at Macmillan at the moment, we actually had a conversation with a company called Global Sign this week, and they have a product called TLS Connect. And TLS Connect will, in essence, allow you to automate certificate rotation. Up until this point, the certificate rotation that we've been doing across our site has been manual. And there are a couple of different reasons why we want to do that. One is because we want to rotate our certificates more frequently to limit the blast radius, but also because sorry, I got distracted. But yeah, also because yeah, you want to limit the blast radius, and also you want to make sure that you're like there's going to be already the certificate lifetime I was going to talk about. The certificate lifetime is down to 200 days at the moment. It will be 100 days by next year, and by 2029 the certificate lifetime is going to be brought down to 47 days. So that's another reason also, and actually with this tooling that we're bringing in place, we can rotate certificates even much more often than that. You also want to think about re-encrypting your data at rest with your algorithm and use short-term session keys to limit your blast radius. And there's no official support for TLS 1.3 in Sitecore XM and XP at the moment, but a feature request has been raised for that. So if you're an XP and XP customer, you have some options to allow TLS 1.3 support. So you can either transition to SitecoreAI, where you will have the Vercel Edge framework, which will handle all of your connections into your site via TLS 1.3. Or you can move to Sitecore XM or XP 10.2 plus headless services with an XJS front end running on Vercel. So you could transition to SitecoreAI using SitecoreAI Pathway. I think it's been mentioned in a couple of other talks. And with the latter option here, you still be stuck on TLS 1.2 for the backend for the connections between your XP services like XConnect and reporting. And you can use, if you want to pass data back to XDB to allow you to still use reporting and analytics within XP, you can use the Sitecore tracking service, for example, to push data through this experience edge layer, which I've got on there. So on here, you see you've got the layout service there. That can also be exposed actually through the experience edge. So you can use your GraphQL endpoints that you'd be publishing to, plus the layout service through there in order to serve content into your Next.js website, for example, hosted on Vercel. This is just an example. You could use other hosting platforms as well, of course. And yeah, the second option here is probably only best for you if you're planning to stay on XP for the foreseeable future, because there would be work involved in moving from JSS to the content SDK if you're moving to SitecoreAI. So before making this decision, if you're an XP or XP customer at the moment and you're not using headless, you probably want to think about, like, do you want to stay on XP for the foreseeable future? If not, probably SitecoreAI might be a better option for you. Post-quantum cryptography, I'll run through the slide really quickly because I appreciate I don't have much time left. But basically, it will move from prime-based cryptography, as I mentioned, and then we'll move to more vector-based cryptography. So in essence, it will use an n-dimensional vector space to solve mathematical problems. And these will be combinatorically explosive. And there won't be any efficient polynomial time algorithm, even for quantum computers, that will be able to solve these types of problems. Obviously, the future also, from all the harvested information, which has probably already been harvested as well, there's going to be, when quantum computing capabilities are available, there will be a huge risk of wide-ranging data breaches from harvested information. That's my talk. There's a link here to my article on LinkedIn if you want to read a bit more about it. And yeah, thank you so much to our sponsors, and thank you for joining my talk.